Hello everyone, welcome to SWAM course on image processing using Python. My name is Dr. Bharti Patel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. In this tutorial, we will explore the world of image processing and how it can be accomplished using the Python programming language. So, let's begin with the discussion for today's topic on review of course materials. As we discussed previously that so many things are there to discussion about the image processing using Python, so we have to see with the glimpse of all the topics, starting with the introduction to digital images and image processing. In that topic we discussed, or we can say that we provide a solid starting point by introducing fundamental concepts and terminology. Then next one is introduction to Python libraries for image processing. Python libraries are very important to know so that we can implement all the programs with the real world applications. So here we discuss the importance for setting up the environment and getting acquainted with the tools necessary for image processing in Python. So in digital image processing, we have to see some of the topics related to knowledge base. In that we have seen the feature extraction and some of the other topics which are related to feature extraction, feature selection and classification. So in digital image processing, these are the sub points which are necessary to include, and according to that we have to learn. So already we have seen in our previous lectures that how digital image processing works with the different areas, with the different applications. Or we can say, like in Python libraries, it is very important to know some of the Python libraries as we discussed. So here are some libraries like Pandas, SciPy, NumPy, Matplotlib, SciPy and Seaborn, Scikit-learn. So all these libraries have their own significance to produce some real kind of applications. So these libraries are specifically using to implement our problems and getting solved by the examples. So like Matplotlib is basically using to implement the equation kind of problems. According to that, we have to take the input and we have to give some equation value and then we have to analyze the result. So we have seen in our previous lecture that how these kind of libraries are very important to know, because the specific library is dedicated for a specific task. According to that, we have to choose the library like Pandas. It is very necessary. NumPy, it is also very necessary and we are using frequently. So these Python libraries are exclusively important to choose a specific area. So next we have seen loading and displaying images using Python. These are categorized according to the topics which we already discussed. So this is the review part about the image processing. So in this we have seen essential for understanding how to work with image data and visualize it within that Python code. According to Python code, we have to learn that how the image is going to produce the output. So for that, initially we have to learn how to load the image and then how to display that image with particular function name, that is called image show. So after that we have seen that basic image manipulation and enhancement techniques. So in our mind it is coming that why it is so important, because image manipulation and enhancement techniques provide the foundation techniques like resizing, cropping and basic enhancements to prepare images for further processing, which is a pre-processing task. According to pre-processing task, we have to implement the image with more accuracy. So it is very important to know the image manipulation and enhancement techniques. So first of all, for loading images in Python, we have some libraries like SkyImage and OpenCV which are going to be used very frequently, and PIL we have to define that word PIL, that is called a pip library. With this library we have to learn that how to import the image and how to load the image. According to that, what will be the output. So these are the loading images using Python. Then some of the principles and basic techniques of image manipulations, like we have to take the image features like texture and the boundary walls and the shadows and some of the other features. These are very basic to know that how image manipulation works. According to image manipulation only, we have to learn that what is the pre-processing, which is a very essential task. So these are the very basic fundamental terms which we have to know, which already covered in our previous lectures. So according to review process, some important topics are necessary to know, which are listed here, like advanced image manipulation and enhancement techniques. It is quite different from basic image manipulation and enhancement technique, because here it takes image enhancement to a higher level, potentially involving techniques like histogram matching or more complex filters. Some of the filters are well known and some of the filters which are just newly joined. So histogram matching is very common technique. Histogram matching which provide the frequency range of that image. According to image, if we want to calculate the equation, so we need to implement the histogram matching. According to that, we can analyze the frequency and then we can project our image. So this is very important to know. Then next one is geometric transformation. Basically, it is a very crucial task like image registration, alignment and perspective corrections. In geometric transformation, we have to give a image with some secret message. According to that, we have to import that image with sufficient code and function, then we can get the output. So here in this image, we can see some of the transformations directions like reflection, enlargement, translation and rotation. Image is kind of an object through which we can move our object from one direction to other direction. So here are listed directions like reflection, we can reflect the same image, original image with another reflection of the other side. Same translation, it is a movement of that particular image with the distance, and enlargement is giving the enhancement of that particular dimension. With the rotation, we have to give the x-axis with the y-axis and y-axis with the x-axis. So all these are comes from the transformations. So next is understanding image color spaces, which is very important to know and we already discussed in our previous lecture. Because of color spaces is having different types of color spaces like RGB, HSV, HSL and grayscale, binary images for binarization and so many things. So it is essential for handling color information in images, which is critical for a wide range of applications. Here color spaces give so many applications like feature extraction, sentimental analysis, face recognition, object detection and some of the important applications in medical field and so many things. So next one is applying color manipulation techniques. In color manipulation technique, it provides practical skills for tasks like color correction, adjustment and manipulation. So in color spaces, we have seen basically RGB is most commonly used, and according to that we have to convert the image, like initially we have to take RGB image, then according to the need we have to convert that particular RGB image to the grayscale image or HSL image or any kind of color space, because RGB is very clear to visible and it is very clear to know that the intensity of that particular color inside that image is here. So according to that we have to change the color space. So different color spaces are there. which we already discussed in our previous lecture. So we have to go through that previous lecture and we can learn that how to convert a specific color space according to our requirement, which is a application based requirement. So another one is understanding image histograms and applying histogram equalization. A key concept for improving contrast and dynamic range in images, we need to apply image histogram and apply the histogram equalization. It is a vast topic to know because histogram itself is a very vast, and equalization and the other method which is included with histogram, it is going to make it very vast. Because equalization need, we have to choose proper color space, then we have to give the frequency value for that particular image. Before that we have to pre-process the image, then we have to provide the histogram. So it is already done in our previous lecture and it is just a review for this histogram equalization. And then next one is applying image smoothing and sharpening techniques. In this histogram equalization, in this image we can see that image is having specific frequency range which is mentioned here with a particular range with y-axis and x-axis, and it is given here in the image. This is the standard image. So next is understanding and applying basic image filtering techniques. So in this we have learned that introduces concepts like convolution, which is fundamental to many image processing operations. Basically, convolution is giving the portion of that particular image we have to take, and we have to extract that image from the original image. According to that we have to switch that image and we have to move forward the updated weighted value. Then that weighted value is giving the final threshold value. According to that we have to learn our image. So applying basic image filtering techniques are like median filtering and mode filtering. This is giving the basic understanding that how the image is correctly identified. So in pre-processing tasks, this is also one of the filtering technique, which is very important to know, because in pre-processing our image quality is improved, then we can say further for feature extraction, feature selection, our image will automatically give the higher accuracy of image. Then the next one is understanding and applying advanced image filtering techniques. It is quite different from basic image filtering technique. Like it dwells into more complex filters and their applications according to the requirement. So by this image we can learn the image filtering, how it works. We have chosen a particular image with the color spaces and then the pixel values are defined. In some cases it is multi-valued, in some cases it is single valued. So single instance filtering is different with respect to multiple instance value, and here pixels are collected according to the requirement, or we can say some technique is required, some filtering technique is applied here. According to that we have chosen a particular set of pixels, and then pixels are creating the another image which is the output image with respect to the input image. So the next one is image restoration techniques. It addresses issues related to noise, blur or other imperfections in images. So noise is a critical part in image. Noise must be removed before going to process for feature extraction and feature selection. So image restoration technique basically provide, like if we have image in the raw form and which is not properly suited for some task, so we have to remove that particular noises like cutting and some kind of blur and some kind of imperfections. So image restoration technique also comes under the pre-processing. So we have also learned all these things like image restoration technique in our previous lectures. You can go through that previous lectures and you can learn how it is going to be applied using Python. Then next is edge detection techniques. It covers techniques for identifying edges and boundaries in images. There are many edge detection techniques which is going for a specific task, like if we want to detect the edges, so we have to apply like canny edges detection technique, and for boundaries we have to apply like scatolization. So some other techniques are there according to the requirement. So this figure shows image restoration. The example of image restoration, how it works. Basically it is a part of a GPU, and we can say we have a core parts in our CPU, so we have to distribute it according to the functionality. In online algorithm, we have to apply a image, and image is segmented and it is parallelly going with the perfection to create a better image. So here restoration technique is used. This is one of the example which already implemented in my MTech work. So I have chosen as an example for this particular topic. And the next one is, here it is age detection. This is the standard image. Here one of the image, it is showing, both the images are showing that how age is detected. The object with the ages is defined with the specific task, like it is called age detection technique with different techniques it is mentioned here. And in all the phases we can see that how age is properly detected and noise is removed. So this is giving a particular object with the dimension that how much it is going to cover the area on that particular image. So next important topic which we already covered, like feature extraction techniques. It is essential for tasks like object recognition and classification. Further, we have to move with the machine learning and deep learning. We need to understand that what is feature extraction technique. Like in our images, so many features are there. One of the feature which is most commonly used, like color. So color is a basic feature, and if we want to extract that color, so we need to extract the pixel. So for that we have different techniques like SIFT and SMTP. Like these are different techniques. According to that we have to extract and we have to recognize the image. That is called feature extraction technique, which is already included with the deep learning. So further we'll see that how it is going to work, and we have seen already that how in deep learning like medical image processing how it works. So next one is understanding image segmentation. It focuses on dividing an image into meaningful regions, which is crucial for object detection and analysis. So basically it is providing the portion of that particular image, we can say the object which we want to actually extract. So this is also a part of feature extraction. So in this image we can learn that how feature extraction works. Here set of images with the different emotions are captured, and it is going to be define that how the emotions are properly fetched. So all the feature extraction techniques are distributed in the vector form. According to that, the emotions are calculated and the image is distributed into two parts, and then it is vectorized, and then the image output is calculated. So next important topic which we covered, thresholding techniques for image segmentation. In segmentation we have different techniques. One of the common technique is thresholding technique. So basically it introduces techniques for segmenting images based on intensity or color thresholds. And the next one is watershed segmentation. It is a more advanced technique for segmenting images with complex boundaries. So for first one we can analyze that how it works. For thresholding we have to give the original image, and in Python code we have to give any format of image like JPG, MPG, any kind of image we can give. So we have given here a TIFF or JPG image format, that is original image, and then we have applied a thresholding segmentation technique, and we can see that object is correctly identified with a circle. Like here we have given a coin as an object, and if we want to extract that object, so it is well verified, objectly defined with that thresholding method. Then the next one is, this is quite difficult to recognize because all the coins are get together with a circle and they are almost overlapping. So this is quite difficult by the simple method which is called thresholding method. So here the watershed segmentation is applied. In this method we can analyze that the somehow overlapping is removed and the objects are correctly identified. The same image we have taken with the different variation. So we can say the complex task is easily solved by this watershed method. Then the next one is understanding object detection and recognition. It addresses methods for identifying and classifying objects within images. And the next one is template matching for object detection. It is giving a specific technique for finding instances of a template, or we can say pattern, within an image. So this example is showing that how we have a different types of images, but if we want to apply a semantic segmentation, it is another kind of segmentation in which we are going to extract the pixel wise the object. So in semantic segmentation, like background is having the different pixel values and the object is having different pixel values. So which is going to be extracted in semantic segmentation. Then in classification we are correctly identified the object, which is called, here in this image we have taken a cat. Then the object detection, which is going to give a different object and we are going to recognize that which object is verified with the name, like dog, cat and some another object. Then the next one is instance segmentation, which is also a different from the semantic segmentation, because in instance segmentation it is quite different in terms of object. So here it is also verified with the same method. Then the next one is introduction to deep learning for image classification and recognition. It introduces a powerful approach for solving complex image recognition tasks using neural networks. And the next one is building a simple image classification model with TensorFlow, which is most commonly used. So it provides practical experience in implementing a basic deep learning model for image classification. So this example shows that how deep learning works with the variations, and it is showing a different layers with the output layer and the convolutional layer, pooling layer, fully convolutional layer and the output layer. It is categorized. The main feature in deep learning which is going to improve this technique is its feature extraction. In machine learning we have to separately include the feature extraction technique, but in deep learning we have to include inside that classification technique. So next one is advanced deep learning models for image classification and recognition. It is likely covers more sophisticated architectures, transfer learning and optimization techniques which are recently used here. And understanding medical image processing, we have taken throughout this lecture some of the applications, and one of the major application is medical image processing. So it introduces the unique challenges and techniques involved in processing medical images. Then the next one is pre-processing medical images. Throughout the medical images, we learn that how starting with the pre-processing and then feature extraction, feature selection and classification, all these stages are very important, and it covers techniques like noise reduction, contrast enhancement and registration specific to medical images. And the segmentation of medical images, which addresses the critical task of identifying and delivering the structure or reason of interest in medical images. Next one is registration of medical images. It focuses on aligning multiple images, and which is essential for tasks like image fusion or tracking changes over time. And the next one is understanding 3D image processing, which is different from medical images. So first of all we have to learn that why it is so important to know in that particular application in medical images, because in medical images we have real time issues. According to that we have to extract the object. Like in a cancer, it is a kind of disease, we have to extract the tissues. For that we have to give the accurate value of that particular image, then only it is useful. Otherwise, if the time delay is required, then automatically that registration process will not work. So in this image processing, it is very helpful for this kind of real images processing. And the next one is understanding 3D image processing. Basically, it expands into the domain of three-dimensional images, which is particularly important in medical imaging. So in this diagram we can see we have a image. The first one is going to give a original image and the next one is giving the 3D image. So first one is dedicated for 2D dimensional and the third one is and the next one is giving the 3-dimensional image, so that we can analyze the throughout the image that how much the color spaces are distributed and then the how frequency are distributed according to the object requirement. So next one is 3D image visualization and manipulation. It introduces tools and techniques for visualizing and working with 3D image data. Why 3D image visualization is important? Because in real time application we have to analyze with all the directions and 3D image visualization and manipulation techniques provide this task. If we have to identify some object which is already overlapped with another object, so these applications are very useful because overlapping will going to create a noise in image and we cannot correctly identify the object. So 3D image visualization is very useful for that particular kind of noises. Then the next one is 3D image filtering and segmentation. Again, filtering and segmentation is also applied in 3D form. In 3-dimensional, filtering and segmentation is enhancing the image quality and extends image processing techniques to 3-dimensional data, which may involve specialized algorithms. So in this diagram, we can see that how data visualization with Python is going to help for 3D images to visualize for real-time applications. And it is distributed with different formats, like pixels are distributed in terms of frequency and in terms of scattered way. Like in clustering technique we can apply and we can choose a particular method to detect that object. According to that, we have to visualize the data using Python. So in this particular image we can learn that how the objects are differentiated with different color spaces. It is very helpful to recognize that particular object, like car is distributed with a blue color and the side road is distributed with a pink color and the walls and the chambers which are distributed with the green colors and the road is a different color. So we can say that in these terms we can distribute the image and we can extract the object. So this is the next example which is showing a medical application. Here it is showing that we have a different kind of images, like MRI we have to take the image and we have to detect a particular disease. For that we have to clarify that particular image. And here it is showing in the first image some noise. We have to remove that noise using applying that particular method of 3D visualization technique and the image is correctly identified and it is easy to process for the next feature extraction techniques. Then the next is image compression techniques. Introduces methods for reducing the storage or transmission requirements of images. And the next one is understanding JPG image compression using Python. It derives into the specific of the JPG compression algorithm, which is widely used in image compression. So in this example, we can learn that how image compression is going to use, which we already seen in our previous lectures, but just a glimpse we have to understand that how it works. Basically we have taken any kind of image, it means any format of image, either it is JPG and TIFF and any kind of image. So we have to analyze the frequency range of that particular image and we have to remove that background so that we can compress that particular image. So here it is properly shown and it is correctly identified with the x-axis and y-axis and the values are defined here for that particular image. The value can vary with the different type of images or different kind of images. Here if we are taking a RGB image, then the frequency value will be different, and if it is grayscale image, then the frequency value is different. So we can analyze a particular color space and with the particular image and the requirement, and we have to justify that particular output. In this image, it is also showing a compressed form with the size and we can say some portion of background. We can compare with the original image, and here the 16 colors are used in that particular image with the range. It is given in y-axis and x-axis, and we can learn that how colors are distributed, and it is going to play an important role for this compression technique. If we want to compress the images, so we have to choose a particular number of colors which we want to extract. According to that, we can compress that particular image by applying the methods. So next one is understanding wavelet based image compression using Python. In this we have seen which covers an alternating approach to image compression using wavelet transforms, and the next one is introduction to image steganography, which introduces the concept of hiding information within images for secure communication. So first of all, we have to learn that what is wavelet based image compression. Here are some steps like quantization and the pre-processing, thresholding, and capturing the image and then compressed images, which is basically a type of wavelet based image compression, which we already discussed that how it works and why it is so important to know. So there are some predefined steps which we already covered in our previous lectures. So in this example, we can see that we have an image, and if we want to hide some data or we want to create a secret message for that particular image and which we don't want to display in front of users. So by this method, which is called steganography, we can use a image to create a secret image, and here it is mentioned as the text which is secretly identified for that particular image. So this is a improved method, or we can say this method is very useful if we want to hide authenticate data. So next one is hiding data in images using Python. It teaches practical techniques for embedding data in images. And next one is extracting hidden data from images using Python, which focuses on techniques for recovering hidden information from images. If we want to extract some information from that particular images, then we need to apply this Python code, which we already discussed in our previous lecture. And if you want to hide some data, then also we have to apply the same technique for this particular method. So overall, this curriculum covers a wide range of topics in image processing, from fundamental concept to advanced techniques, including specialized application in medical imaging and 3D processing. It provides a comprehensive and practical introduction to the field. However, the effectiveness of the course will also depend on the quality of instruction, hands-on exercises which are already included with all the lectures, and the availability of resources for further exploration. If you have any more questions or need further help in the future, don't hesitate to reach out. Happy learning and best of luck with your endeavors. Have a great day. Goodbye. Thank you.